Hello and welcome back to this channel. Dear students, today's session is for conversion of number system. This is part 2. Earlier I have created conversion of number system part 1. I hope you have watched that video. If you haven't, do watch that video. I will provide the link in the description box. As such, the conversion of number system part 1 and part 2, these are very much straightforward. You don't have to even do the practicing of such numericals. Once the concepts are clear, you can convert any type of number from one system to the another. Now, as far as this part 2 is concerned, first part is we'll discuss how to convert hexadecimal number into the decimal number system. Before that, you need to memorize some basic things. Hexadecimal means, do remember like this, hexa means 16. So 0 to 9 numbers are used, and for 10 letter A is used, for 11 letter B, for 12 letter C, for 13 letter D, 14 E, and for 15 letter F is used. Numbers 10, 11 are not used. Then in this system you have to make a group of 4 because its base is 16 and the sequence is 8, 4, 2, 1, or from the right to left 1, 2, 4, 8. On the contrary, if you are talking about octal number system, its base is 8. You need to form the group of 3, 1, 2, 4. Okay. So first part is how to convert hexadecimal number into the decimal number. Let us directly start with one example. Suppose I have one number 4C8.2. The question in the example will be like this. This number will be given. It is hexadecimal number. So base 16 will be written and it is asked like this. How will you convert this hexadecimal number into decimal number? Just by looking at the base, you will come to know which type of number system is there. Base 16 means it is hexadecimal number system. Base 10 means it is decimal number system. That means you have to convert hexadecimal number system into the decimal number system. Like the earlier case, make the thing simple. I will rewrite the number like this, 4C8. This is decimal point 2. We know that this part which is earlier to the decimal point is known as integer part. So 4C8 is integer part. The part which is after decimal point is the fractional part. So 2 is the fractional part. The calculations are pretty simple. Keep the decimal point as it is. For the fractional part, go on multiplying. This number is 2. Go on multiplying it with 16 raised to minus 1. Then suppose one more number would have been there. I would have multiplied that number by that number into 16 raised to minus 2, then minus 3, and so on. On this side, from RHS to LHS, consider the number. First number is 8. It is 8 into 16 raised to 0. Do remember, after decimal point you need to multiply the numbers by 16 raised to minus 1, minus 2, minus 3. Then before decimal point, from right to left, go on multiplying each value by 16 raised to 0, 16 raised to 1, and so on. Now, this is letter C. I have given you the reference. Letter C is corresponding to number 12. So don't keep C as it is. It is basically 12 into 16 raised to 1. Next number is 4. So very simple, 4 into 16 raised to 2. Likewise, perform the calculation. Just you have to take the multiplication. So this answer will be 1024. Then 12 into 16 will be 192. 16 raised to 0 is 1. So it is 8.2 into 10 raised to 16 raised to minus 1. It is 125. So 0.125. So whatever multiplication you have performed, just add the results of all multiplication both at LHS and at RHS. After decimal point, I have only one number, so I am keeping it as it is. So just add all these values. So final answer will be 1224.125 and its base is 10. So very simple trick. So by this way, you can convert any number from hexadecimal to the decimal number system. Now reverse way. Suppose the number is given in decimal number system and it is asked to calculate its hexadecimal equivalent. For example, if the question is like this, 175.23 and its base is 10. So from the base we can well judge it is the decimal number system. the question will be like this, in the bracket question mark and base 16. That means it is asked to convert this decimal number system into hexadecimal number system. So this is the next type of conversion, decimal into hexadecimal number system. Now how to do it? What we studied in part 1, the analogy is very much similar, only the values are different. Consider the integer part separately and decimal part separately. First, we will consider integer part. Integer part is 175. Integer part is the part before the decimal point. Now go on dividing it by 16. Why 16? Because you are converting it into hexadecimal. Base of hexadecimal is 16. So first step, I will write it over here, 175 divided by 16. Divide this number integer part by 16. Calculate its answer on the calculator. So this answer will be 10.9375. What I did, I have taken this integer part divided by 16 and I have generated the answer on the calculator. It is 10.9375. Then make two columns like this. First is quotient and second is remainder. So quotient in this case is 10. I will write it 10. How to calculate a remainder? Very simple trick I will tell you. Consider the value after decimal point. It is 0.9375. Multiply this value by 16 because it is hexadecimal. So you will be doing it like this, 0.9375 into 16. Whatever answer you will be getting, that will be the remainder. It is 15. On the calculator, this answer is 15. But it is hexadecimal, so any number after 9 is not allowed. Look at the equivalent table, equivalent value, 15 stands for F, so this value is actually F. Now, next thing, consider this quotient, that is 10, so I will write this 10 over here in the next step. Then divide it by 16. Every time, consider the quotient after one division, divide that by 16. But here, 10 is less than 16, so you cannot divide it ideally. So its quotient is 0. Remainder is naturally number 10 because you are not performing complete division. So quotient is 0, remainder is 10. You are dividing 10 by 16, but 10 number is not allowed. So equivalent letter for 10 is A. So that's it. You got the 0 remainder. If in case you are not getting the 0 remainder, go on doing the calculation till 4 to 5 steps. That is more than sufficient. Now, how to write the answer? This is just the integer part. For integer part, write the answer from bottom to top. So, answer of only integer part, that is 175. I am writing it from bottom to top. So, it is AF. Now I need to consider the fractional part. Fractional part in this case is 0.23. So I will be doing calculation over here. Fractional part is 0.23. Now this calculation is very simple. What we did in integer part, we have divided every time by number 16. In case of fractional part, do it in reverse way. Multiply the value. Now in this case value is 0.23 by 16. So it is 0.23 into 16. Answer is 3.68. You just have to write one column. You just have to add one column, that is the carry. In this case, carry is very simple. Carry is the part or number just before the decimal point. Before the decimal point, I have integer 3. So it represents carry. So carry in this case is 3. Now, next part. Consider only the fractional part. This is the first step. What I did, I have taken this decimal number, that is 0.23 multiplied by 16. Answer is 3.68. Whatever integer part is there, I have written it below the carry column. So carry is 3. Now second step. Consider this fractional part, which is 0.68, again multiplied by 16. Calculate the answer on the calculator. It is 10.88. So carry is integer part, so carry is 10, but 10 corresponds to A. So I am directly writing carry is equals to A. Now consider the fractional part. So fractional part is 0.88. So I will be doing like this, 0.88 into 16. Calculate the answer. This is 14.08. So integer value is 14. Look at the corresponding value. 14 stands for E. So carry, I will be writing it as E. Now fourth step. Consider the number after decimal point, that is the fractional part, that is 0.8. Again multiply it by 16. So answer will be 1.28. So carry is the integer value, that is 1. We have done this up to 4 steps. It is more than sufficient as far as exam point of view is concerned. But this is the fractional part which we got after multiplying it by 16. So you should write it from top to bottom. Very simple rule. For first part, for 175, where I perform the division, write it from bottom to top. For fractional part, where I perform multiplication by number 16, write it from top to bottom. So this corresponding answer is 3AE1. How to write the final answer? Final answer is pretty simple. You will be writing it like this: 175.23 base 10, that is the decimal value. Its corresponding equivalent value in case of hexadecimal form is, first write the initial answer, that is AF, then dot, that is decimal point, 3AE1. So this is the way how you can convert any decimal number into the hexadecimal form. The next part is how to convert binary number into the hexadecimal number. Consider one example. Here some sequence of binary numbers is given. Base is 2, so it clearly indicates it is a binary number. We have to calculate its hexadecimal equivalent because base is 16. How to do it? I have written the rules in a simplified language. In case of hexadecimal, make a group of 4. Do remember this concept. For hexadecimal, make a group of 4 and write down the numbers 1, 2, 4, 8 below each group. How to do it? See, do remember we have to make a group of 4 bits. Consider this given number. As far as decimal point is concerned, I will mark decimal point over here. After decimal point, I have only 3 values. That is 1, 1, 1. I have to make a group of 4. So just go on adding whatever required number of zeros. So since after decimal point I have 3 bits, that is 1, 1, 1, and I have to make a group of 4. 1 bit is remaining, so I will add 1 extra 0. Now for this part, again you have to make a group of 4, but don't get confused. Do remember like this: when you are making a group of 4 after decimal point, read from decimal point towards the end, towards RHS side. Whereas for integer part before decimal point, go on reading it from left to right, from left to right. So I have to make a group of 4. How to do it? I am reading it in a reverse way from this point. That is, first I will write the first group, that is 1, 0, 1, 1. I am reading it from right to left. So it is 1, 1, 0, 1. This is one group where I have considered this 4 bits. Now remaining bits are 1, 1. I am reading it in reverse way, that is right to left for the part before decimal point. So this is group of 4. This is group of 4. Now there are only 2 bits remaining. So 2 bits are required to make a group of 4. So I will add 2 zeros before this. Now after this, again this is one group of 4. Likewise, I have formed the group of 4 bits. Then below each group, go on writing the corresponding values in this sequence, that is 1, 2, 4, 8. I am reading from right to left. So I will be writing the values 1, 2, 4, 8. This you have to write below each group like this. Now very simple. This 8 is getting multiplied with 0. So answer is 0. 4 into 0, 0. Add these values. 2 into 1, 2, plus 1 into 1, 1. This is first part. So its answer is 3. Likewise, for the second part, this 1 into 1. So, or you can well start from this point. 8 into 1, 8. Plus 4 into 0, 0. Plus 2 into 1, 2. Plus 1 into 1, 1. So this answer is 11. Next, mark the decimal point as it is. For this part, again 8 into 1, 8, plus 4 into 1, 4, plus 2 into 1, 2, plus 1 into 0, 0. So this answer is 40. But numbers in hexadecimal after 9 are not allowed. So look at the table. 11 stands for letter B. So I will write this number as 3, then B, 4, 3B point, decimal point will be as it is 14. Number 14 is corresponding to letter E. So answer is 3B point E. Its base is 16. This is the way how you can convert binary into the decimal form. Next is reverse way. How to convert hexadecimal number into the binary number. Suppose 8A9.B4. This is the given hexadecimal number. Its base is 16. We have to convert it into the binary form. Again, do remember the basics. Hexa means base is 16 and the corresponding group should be group of 4 and the sequence is 8, 4, 2, 1 or from right to left 1, 2, 4, 8. Now, I will rewrite the given number as it is for the simplicity. So it is 8A9.B4. Now, I have to consider this sequence 8, 4, 2, 1. Make the thing simple. The given sequence is, I will write it over here, 8, 4, 2, 1. Think of 8 only. How can I generate this 8 by using this system? This 8 will be multiplied with 1. That's it. So it will generate 8. Remaining things should be multiplied, that is 4 to 1 should be multiplied by zeros, because after adding all these values, after taking multiplication and after adding, I am going to generate this bit. So it's pretty simple. I have considered only number 8. Then for 8, I have written this sequence 8, 4, 2, 1. I want to generate 8. So this 8 should be multiplied with 1. For all other digits are not required. So it only 8 should be generated. So for 8 I have written 1. So corresponding binary digits for this is 1, 0, 0, 0. And I know that for hexadecimal I have to make a group of 4. Then consider number A. Look at this part. Number A is corresponding to 10. So I have to generate 10 by using the same sequence. How to generate 10? 10 is basically 8 plus 2. So for 8 I will write 1. For 2 I will write 1. For 4 and 1. This is 0, 0 because 8 plus 2 becomes 10. So corresponding binary is 1, 0, 1, 0. Then on the same lines, consider number 9. How to generate number 9? I have to now generate number 9 using the same technique. I can apply the similar logic. Number 9 can be generated as 8 plus 1. So for 8 I will write 1, for 1 I will write 1. The remaining two things should get multiplied with zeros. So corresponding binary value is 1, 0, 0, 1. Keep decimal point as it is. Then next number is B. B is corresponding to 11. So I have to think of generating 11. How to generate 11? It is 8. For 8 I am writing 1. Then 8 plus 2, 10 plus 1, 11. 4 is not required. I have just added 8 plus 2 plus 1 to generate 11. So corresponding value is 1, 0, 1, 1. So for B, I got 1, 0, 1, 1. Now think of number 4. So very simple. Only number 4 is required. So for 4, below 4 I will write 1. For remaining digits, I will write 0. So it is 0, 1, 0, 0. Now final answer is simply written like this. 1, 0, 1, 0, 1, 0, 0, 1.1011 and 0, 1, 0, 0. Its base is 10. So it's pretty simple. This is the way to convert hexadecimal number into the binary number. Next is octal to hexadecimal conversion. Again, stick to the basics. Octal means base is 8. You have to make a group of 3 and sequence is 4, 2, 1. Hexadecimal means base is 16. You have to make a group of 4. Sequence is 8, 4, 2, 1. Suppose I have to convert this number 670.17. Base is 8. So it is octal into the corresponding hexadecimal value. How to do it? I will write this number separately. 670. This is the decimal point 17. Now, since it is the octal number, first I have to convert it into binary. Very simple trick I am telling you. So for octal, sequence is 4, 2, 1. Like the previous case, I will write the sequence over here 4, 2, 1. Think like this. I have to generate first number 6. So how to do it? 6 is basically addition of 4 and 2. So corresponding value will be 1, 1, 0 because it is 4 plus 2. So for 6, I will write 1, 1, 0. Then suppose I have to generate 7. For 7, I have to add all these values, 4 plus 2 plus 1. So it will be 1, 1, 1. Below each value, I need to write 1. Whatever values you are taking, below that write 1. If you are not taking any value, below that write 0. So it is 1, 1, 1. Next, 0. So 0 remains as it is because I don't have any value. So 0, I am keeping it as it is. Point. Now I want number 1. Again consider this system. 1, 2, 4. So number 1, below number 1, I will write 1. Remaining things are 0. And for this 0, since I have to represent it in terms of 3 bits, so I will write 0, 0, 0. This decimal point as it is. For 1, I got 0, 0, 1. So 0, 0, 1. For 7, just now we discussed, it is 1, 1, 1. So this is the case in which I have converted given octal number into the binary form. Now I have to convert it into hexadecimal. To convert it into hexadecimal, just now we learned, this is, consider now this is a binary. You have to convert it into hexadecimal. You have to make a group of 4. Now how to do it? Keep this decimal point as it is. I am keeping this decimal point as it is. Part after decimal point, start reading that part from decimal point towards right hand side. So make a group of 4. So this is 0, 0, 1, 1. I have considered these 4 bits. Then remaining bits are 1, 1. Again I need to add 2 zeros because I have to make a group of 4. So it is 0, 0. Very simple. These first 4 bits I have taken it as it is. Only 2 bits are remaining. I have to make a group of 4 because I want to convert it into hexadecimal. So 1, 1 is taken as it is. Add 2 zeros. Keep decimal point as it is. The part before decimal point, start forming a group from right to left. So this will be the first group of 4. 0, 0, 0, 1. I am doing it in reverse way because this is the part before decimal point. So I have finished this part. Then consider 1, 1, 0, 1. So this is 1, 1, 0, 1. I have also finished this part. Remaining number is 1. I need to write it as it is and I have to make a group of 4. So add 3 zeros. So this is the way how I have formed the group of 4. So I will just highlight the group of 4 which I have formed like this. Now this is the binary which I have expressed in terms of hexadecimal point. So for hexadecimal, we know the sequence. Sequence is 1, 2, 4, 8. Just now we have discussed the same sequence. Consider this number, first group 0, 0, 0, 1. So it is 0, 0, 0, 1. Corresponding value will be 1 into 1, that is 1. Next 1, 0, 1, 1. So below this I will write this corresponding value. So it is 1, 0, 1, 1. Very simple. It is 8 into 1, 8. Plus 2 into 1, 2. Plus 1 into 1, 1. So it becomes 11. This value is 11. But it is hexadecimal. 11 is not allowed. So 11 stands for B. So corresponding value is B. Next 1, 0, 0. Below this I will write 1, 0, 0. So answer will be naturally 8. All the values, other values are getting multiplied with 0. So this answer will be 8. Point. Next is 0, 0, 1, 1. So you just have to take multiplication of 2 into 1 plus 1 into 1, that is 3. So this answer is 3. Next is 1, 1, 0, 0. 1, 1, 0, 0. So it's simply 8 plus 4, that is 12. But 12 is not allowed. For 12, I need to write C. So answer is 1B 8.3C to the base 16. So this is the way how you can convert from octal to hexadecimal. The last part of conversion is hexadecimal to octal. It is again on the same lines, just stick to the basics. So base is 16C, it is hexadecimal. I will write it like this, 2A.9. This is the number I have to convert it into octal. First I will try to convert it into binary. Do remember for hexadecimal sequence is 8421. Consider first digit, that is 2. How to represent 2? I want to generate 2, so it will be naturally 0, 0, 1, 0. Very simple. Below 2 I have to write 1. All other values are getting multiplied with 0. So for 2 I got 0, 0, 1, 0. I am converting each number into the binary. A stands for 10. So I have to consider number 10. For 10, it is 8 plus 2. So I will write 1, 1 below 8 and 2. For remaining bits, I will mark 0, 0. So it is 1, 0, 1, 0. Next is number 9. For 9 is generated by adding 8 and 1. So below 8 and below 1, I will write 1, 1. At other places, I will write 0, 0. So it is 1, 0, 0, 1. Decimal point is as it is. But this is not the hexadecimal to binary conversion. What is asked? It is asked to convert hexadecimal into octal. Octal means base is 8 and make a group of 3. So to form the to convert the number into octal, I have to make a group of 3. Again, keep decimal point as it is. What I said, the rule is very simple. Points, digits after the decimal point, start reading it towards the end, from decimal point towards the end, towards RHS. So first group will be like this, 1, 0, 0. Now only one bit is remaining, that is 1. So I have to add 2 zeros to form a group of 3. This is the decimal point. Now part before decimal point, start reading it from right to left and form group of 3. So first is 0, 1, 0. I will write it like this, 0, 0, 1, 0. Next group, consider this group, 1, 0, 1. Next there are 2 zeros. I will first write it as it is, but one bit is remaining to form a group of 3. So I have added 1, 0. Now for each group of 3, I will have to write corresponding octal value. So I have just highlighted the group of 3 bits. Now for the 0, 0, 0 corresponding octal value is 0. Do remember, for octal we have the sequence 4 to 1. So for the reference, I will write this sequence 4 to 1. To generate 0, I don't have to use any one of these numbers. So I am directly writing 0. Then 1, 0, 1. Below this, I will write 1, 0, 1. So it is 4 into 1, 4 plus 1 into 1, 1. So it is 5. So 1, 0, 1 corresponds to 4 plus 1, that is 5. Next is 0, 1, 0. So below this I will write 0, 1, 0. Very simple. It is only 2. All other values are 0. Keep decimal point as it is. Next is 1, 0, 0. Below this I will write 1, 0, 0. Answer will be 4. Just now we discussed the procedure. Next is again 1, 0, 0. So answer is 4. So corresponding value is 052.44. Base is 8. So this is the way how to convert hexadecimal into octal number. Dear students, that's it. This is the end of conversion from one number system to another system. It's a pretty simple part. Only you need to stick to the basics. So that's it for today's section. Thank you. Thank you very much.